Hello everybody, welcome once again. We are in our fourth module and we are studying about the problems on projectile motion. So already we have seen 4 problems on the last video and here we are going to see some more problems on projectile motion. So we will go on to the problems. So the problem is a projectile is fixed with a velocity of 500 meter per second at an angle of 30 degree. Find the velocity and the direction of the projectile after 30 seconds of its firing. So we can see the projectile motion, and this projectile motion, this object is projected with a velocity of 500 meter per second and the angle of projection is 30 degree. We are asked to find the velocity and the direction of the projectile after 30 seconds of firing. So just imagine after 30 seconds the object will be at this point. So after 30 seconds at this point, what will be the velocity and what will be the direction of velocity? So what is the velocity and what does this velocity makes with the horizontal? What angle this velocity makes with the horizontal? That is our problem. So we will take our initial velocity as u and our final velocity, that is after 30 seconds the velocity as v. So first of all we will consider the x direction. So by considering the motion in the x direction, that is at initial position u, velocity in x direction, velocity is 500 meter per second. So in x direction the x component of velocity is 500 cos 30. So we get 500 cos 30 as 433 meter per second. And in x direction we know the acceleration due to gravity is 0 and time is taken as 30 seconds. So after 30 seconds the final velocity v will be, we know the equation v is equal to u plus at. So using that equation in x component, x direction, vx, that is component of velocity in the x direction after 30 seconds, is equal to the initial velocity of x component ux plus at. So a is equal to 0. So we get the x component will be same. Ux is equal to vx. So that is equal to 433 meter per seconds. Now we will consider the y direction. So in y direction, the velocity component in y direction is 500. So this direction, this is 500 sine 30. So we get 500 sine 30 as 250 meter per second. And the projectile motion is upward motion. So this is upward motion. So our acceleration due to gravity is taken as minus g. So it is minus 9.81 meter per second square. And time is taken as 30 seconds. So the velocity after 30 seconds will be v in y direction. That is y component will be vy is equal to uy plus at. A is minus g here. So we get minus 44.3 meter per second. That means here the velocity component in y direction will be the downwards movement. Downward. So you can see it from the diagram also. That is at the initial point, here the y component of velocity is upwards, here the y component of velocity is downwards. So we get automatically it is minus 44.3 meter per seconds. Now the velocity after 30 seconds, that is at this point our velocity will be equal to vx square plus vy square. Vx is v cos theta and vy is v sin theta. So vx we have already found 433 and vy is minus 44.3. So we take the square root of these both, we get 435.28 meter per. So now theta is equal to tan inverse of Vy by Vx. So we get 5.84 degrees. Now we will go for the next problem. Problem 6. The horizontal range of a projectile is 3 times the maximum height. Find the angle of projection. So we know the formula for range is u square sine 2 theta by g. Formula for maximum height of the projectile h max is equal to u square sine square theta by 2g. So the condition is the range of the projectile is 3 times the maximum height. So r is equal to 3 times h max. R is equal to 3 times h max. Substitute, we get theta is equal to 53.13 degrees. Next problem. A bullet is fired at 125 meter per second from a point A and has to hit a target at a horizontal distance of 100 meter from A and situated 200 meter higher than A. Find the angle theta at which the bullet must be fixed in order to strike the target at the maximum time. Part B, find h max above A reached by the bullet, and C part, find the time of flight. So similar to the previous problems, a bullet is fired at 125 meter per second from a point A. So from point A it is fired, the bullet is fired with a velocity of 125 meter per second. It has to hit a target at a horizontal distance of 100 meter. So for a distance of 100 meter from A and situated 200 meter higher. So this y is 200 meter, x is 100 meter. So your projectile will be like this. So now find the angle. We have u is equal to 125 meter per second. So u cos theta is the x component and u sin theta will be the y component. Now you can find Sx. Sx, that is horizontal distance, is 100 meter. So you can use S is equal to ut plus half at square for x direction and y direction. So find t from the x direction, substitute it in the y direction. We will get two values for theta. One value is 32.789 degrees and another is 68.535 degree. So when theta is equal to 32.789 degree, we will get minimum duration, that is 9.5162 seconds. And when theta is equal to 68.535 degrees, our time taken will be maximum, and that is equal to 21.86 seconds. So this problem is a practice problem for you. Do this. Now second part, that is find h max above A reached by the bullet. What will be the maximum height reached by the bullet? So we know at maximum height the velocity will be equal to 0. So substitute at h is equal to h max, Vy is equal to 0. H means height, that is the vertical distance. So for the vertical distance, when it is h max, Vy will be equal to 0. And substitute V square is equal to u square plus 2as. We get h max is equal to 233.557 meter. I repeat, at h max, when the bullet is reaching the maximum height, velocity will be equal to 0. So we know velocity, that is final velocity, v square is equal to u square plus 2as. So substitute v square is equal to 0. So you get, substitute Vy is equal to 0, we get h max is equal to 233.557 meter. Now we will go for the next example. A stone is thrown down the slope as shown in the figure. So this is different from the previous problems. Previous problems, the target was either it lies on the horizontal line or above, height above the horizontal line. Here it is lying, the target is B is lying below the horizontal line. So now a stone is thrown down a slope as shown in the figure. Determine the magnitude of initial velocity u and direction theta, so that the stone will rise 12 meter and still have a range of 50 meter down the slope. So from when you throw the stone from A, it reaches a maximum height of 12 meter. So this is 12 meter and the range, that is from A to B, the distance from A to B, the range is 50 meter. Now this angle is taken as theta and the angle between the projection and the horizontal is taken as alpha. So here on the inclined surface, this is given as 4 and 3. That is the horizontal component is 4. That is the inclined plane is in the ratio of 4:3. 4 horizontal and 3 vertical. Therefore, if it is 4 horizontal and 3 vertical, the inclined will be 5. It will be 3:4:5. We take it as a right angled triangle. It is 4:3:5. So now this is 50. See, this range is 50. That means our Sx, this will be in the ratio. We know, see, when we are taking a right angled triangle, the ratio will be 3, 4 and 5. So this inclined ratio is given as 50 meter. So your horizontal distance will be, that is Sx will be 40 meter and Sy will be 30 meter. Now in x direction, we know S is equal to ut plus half at square. So in x direction, ux is equal to u cos alpha. And ax is 0, acceleration due to gravity is 0, and sx, that is horizontal distance, is 40 meter. So this u is resolved into horizontal component and vertical component. So when we are resolving it into horizontal component, it is u cos alpha. Now we will substitute S is 40, Sx is 40, u cos alpha into t. And acceleration due to gravity is 0, so this term becomes 0. So from this equation, our t is equal to 40 by u cos alpha. Now we take the y direction. So distance of y is, that is uy is equal to u sin alpha. Component of velocity is u sin alpha. Ay is minus 9.81 meter per second square. And sy is taken as 30 meter, this distance. See, this sy is from the horizontal plane to the inclined plane. This is 30. So it is downward from the horizontal axis. So we take it as minus 30 meter. So when we are substituting in the equation S is equal to ut plus half at square, we get minus 30 is equal to u sin alpha into, substitute the value for t from x direction, plus half into a is minus 9.81 into t square. T is 40 by u cos alpha, the whole square. So we get, substituting t, we get, the only unknown is alpha, we get alpha is equal to 59.863 degree. Alpha is equal to 59.863 degree. Now you can see the diagram. This angle is beta. See, this angle is beta. So if this angle is beta, this angle also will be equal to beta. That means theta is equal to alpha plus beta. Okay. So theta is equal to alpha plus beta. So we have calculated beta. Beta is equal to this 30 by 50. Sin beta is equal to 30 by 50. We get beta is equal to 36.732 degrees. Now theta is equal to alpha plus beta. We get 96.732 degrees. Now our velocity u is equal to square root of ux square plus uy square. So we get 17.742 meter per second. So that's all for today. Thank you. Hope you all understood. If you have doubts, you can comment on the session. Thank you so much.